Hi, welcome to Turkish Engineering. In this lecture, we are going to study Chapter 3 and Part 1. Okay, so this is velocity in a plane. As I said, we are starting with translational motion, and we will study translational motion in the plane. So it will be two-dimensional. Okay, and I skipped one-dimensional motion. So let's study the velocity in two dimensions. Actually, when we are talking about two dimensions, we must put our coordinates. We have two axes, the y-axis and the x-axis. Okay, I will first put my path. Okay, we can have multiple types of path. So it can be linear, okay, rectilinear, just like this. Okay, it can be my path. My path can be curvilinear, like this. Okay, or some different types. Okay, so I will put just two different paths. Okay, one of them will be just curvilinear, and the other one will be rectilinear. Okay, two different paths. So in the first graph, okay, I will just draw two different graphs. Let's put them. So the first graph will be just rectilinear. Okay, rectilinear. So I will put my path. Okay, my path is linear and parallel to the x-axis. Okay, so this is actually, this will be, if I have rectilinear motion and it is parallel to the x-axis, so that means that I am not moving in the y-axis. So that will be one-dimensional. So as I said, we will study two-dimensional. So I will put my path like this. It will be linear, but my path way and my path angle must be inclined way. So I must have velocities in two directions, in the y-axis and in the x-axis. So I will just draw this line, this straight line, but it will be with an angle. Okay, so my path will be with an angle. So let's put our angle. Okay, so let's put our path. It will be, as I said, an inclined path. Okay, just let's put better. Okay, so this is my path. I will start in from the origin. Okay, so I have this path, and let's put our angle. Okay, this is inclined, our path is inclined, and I have just an angle theta. So let's put this is my path. Okay, path of the motion. This is my path. And where is my velocity? Actually, if I'm moving in this path, my velocity must be in this direction, right? In this, onto this path. So it will be tangential to this path, and that means it is onto this path. Okay, so I will put my velocity. Vector. Okay, so it will be just like this. So let's put our velocity vector. This is my velocity vector. Okay, just put as v. As you see, I have two different components. Actually, I'm moving in two directions, in the x-axis and in the y-axis. So I must know what are my components. What is vx and what is vy? Okay, how can I know this? I will just calculate this by basic knowledge of triangle. Okay, just zoom to the vector. Okay, this is my vector. This is my resultant velocity, the total velocity. But I must have two different velocity vectors. One of them in the x-axis, like this, and the other one in the y-axis, right? So let's put the other one. So this is vy and this is vx. As you see, I have an angle theta here, and this is a basic triangle. So just put some basic trigonometry. Okay, what is sine theta? Sine theta will give me the opposite one, okay, divided by hypotenuse. So it will be just vy divided by v, right? So if I want to calculate what is vy, so vy will be equal to just v multiplied by sine theta. Just I'm moving this v to the other side. I'm multiplying both sides by v, so I will get vy equals to sine theta. What about the second formula for vx? Cosine theta will be just adjacent divided by the hypotenuse, right? So I will get Vx divided by V for cosine theta. So I can say that Vx, when you multiply both sides by V, you will get Vx will be equal to V cosine theta. So these are my formulas. So if you know your velocity vector, what is the magnitude of your resultant velocity, so you can calculate what is your component in y-axis and what is your component in the x-axis. So these are simple principles for vector operations. Okay. So, but what about the magnitudes? If I know V and if I know Vy, how can I know Vx? If I know two of them as a magnitude, how can I know the other one? As you know, we have a Pythagorean theorem which is coming from geometry. So v squared, this is coming from geometry. So v squared must be equal to one of the, just say the rise one, the Vy, okay, and the run one, this one, okay, our base and our height. Just take square of them and add them, okay. So Vx squared plus Vy squared must be equal to V squared. It is coming from geometry and it is a Pythagorean theorem, okay. So by this way you can say when you take square root of both sides, you will see that our velocity magnitude will be equal to square root of our x component squared just plus our y component squared. Okay, this is the third formula which we will use. Okay, so this is our third formula. Let's put this one. Just some simple formulas. This one, and this one. What about if I have a curved path? Okay, I will have a different path now. Okay, this is my path. So, in this case, actually your direction of the vector will be different in any point. So in each point you will have different vector, because your vector must be tangential to your path, and your path actually is not just a straight line, it's just curved. So at this point I will have a vector which is in this direction. When I'm reaching here, my direction will be just like this. When I'm reaching here, my direction will be like this. When I'm here, our vector will be like this. And when I'm here, our vector direction will be like this. So each of them has Vx, and each of them has Vy, right? So here this is V and this is V. As you see, the Vx will be more and here Vy will be smaller until you reach the maximum point. Here you will see that your velocity will be just parallel to the x. That means you don't have any y component and you have maximum x velocity. So this is the idea, and this is curvilinear motion. So the velocity vectors for the curvilinear motion will be like this, and you will use the same formulas. Vy will be equal to V sine theta, Vx will be equal to V cosine theta, and this one for calculating the magnitudes. Okay, so this is the idea for velocity in a plane. So let's take one example to understand more, then solve two problems. So in this video we will take just one example, and for the next video we will solve two different problems for velocity in a plane. But before the example, I will just explain what's velocity. Actually we put our velocity, but we didn't put what actually velocity means. Okay, so velocity will be equal to, it's actually vector quantity which has both magnitude and direction. Okay, so it will be just a vector quantity. So that will be equal to our displacement. Okay, just delta r will be displacement. Okay, displacement per unit time. Okay, displacement per unit time. Okay, so this is time change. Okay, change in time change. So you have displacement of 5 meter and you just made this displacement in 5 seconds, okay, in 5 seconds. So that means per each second you moved 1 meter, okay. Your average velocity will be per each meter you will need 1 second. So your velocity will be meter per second. Velocity unit will be meter per second, okay. This is SI unit, meter per second. So this is our velocity. What about Vx? Vx will be just the displacement change in x-axis. So it's just delta x. That means displacement in x-axis. Actually, delta r will be equal to r final minus r initial, okay. The final vector, the final position minus initial position. What about delta x? So I have delta t here, which is displacement per unit time, but in x-axis only. So that will be x final minus x initial divided by delta t, okay. What about Vy in the y-axis? Actually, that will be the displacement in y divided by the time change. And that will be y final minus y initial divided by delta t. So let's say that my initial position is here and my final position is here. So this will be this straight line between these 2 points will give me delta r, okay. This is delta r, and I have 2 axes, right? I have 2 axes, so I must have 2 different actually vectors, 2 different components of this one. So I will put my components here, okay. So this one will give me delta x and this one will give me delta y, and I have here just an angle. So you will use the same idea. Delta r will be equal to square root of delta x squared plus delta y squared. The same Pythagorean theorem, okay. So what about the angle, this one, the theta? How can we calculate theta? Actually, tangent of theta will give us the opposite divided by adjacent, right? So delta y divided by delta x. So if you take arctangent, the inverse of your tangent function, inverse of delta y divided by delta x will give you the angle theta. So this is one of our equations, and this is the other. And we can use this idea for angle theta in velocities also. So between each velocity, this angle can be calculated by the same idea. I will put here our velocity angle formula. So the tangent of theta will give me Vy, because it is the opposite, and Vx is the adjacent. So if I take arctangent and inverse of tangent of Vy divided by Vx, okay, if I take the Vy divided by Vx, arctangent of it, so I will get our angle theta, okay. So this is this will be one of our formulas. Arctangent of Vy divided by Vx will give me the angle, okay. So I will move here again. So this is my delta r, which is displacement in 2D, okay, in 2D, the resultant of our displacement, the total displacement. But I moved actually in 2 different dimensions. So delta x and the other one is delta y, okay. So we will use just basic triangle and basic triangle geometry to understand the relations between them. So let's move to the example. Yes, in this example we are moving in xy plane, okay, and you place the origin at your own location, okay, in your location. So at time, when time equals to 2 seconds, the car has x and y coordinates of 4 meters, 2 meters. So that means your x coordinate is 4 and your y coordinate is 2 meters. And at time, when time is equal to just time sub 2, that means the final time, your time, this time is 2.5, okay, seconds. It has coordinates of 7 meters and 6 meters. For the time interval from t1 to t sub 2, find the components of the average velocity of the car and the magnitude and direction of the average velocity. So I will put my, my basic knowledge. So I will put t1, okay, at t1, my locations, okay, so x1 is, as you see, 4 meters, okay, 4. And what about y1? Y1 is 2 meters. What about T2? When I reach to T2, my final x position will be 7 meters. And what about y2? I have 6 meters. So as you see, if you have position change, okay, that means you are making a translational motion. If your position is changing, your location is changing, so you are making a translational motion. So how can we calculate the velocity? If you know the displacement, when you divide the displacement by the time, you will get your velocity. So I will put Vx. Vx will be equal to delta x divided by delta t. Let's calculate here delta t. Delta t will be equal to t sub 2 minus t sub 1, the final time minus initial time. Our final time is 2.5 and initial time is 2. So I will get 0.5 seconds. What about delta x? Here I will put my x final, okay, x2 minus x1 divided by delta t. I know delta t, it's 0.5 seconds. So here I will put x2, 7 meters minus 4 meters divided by 0.5 seconds. That will give me 3 meters divided by 0.5 seconds. So that will be equal to 6 meters per second. Okay, 6 meters per second. This is my velocity in the x direction. What about the y? So I will put the y. That will be displacement in y divided by the time change. So y2 minus y1 divided by the delta t is just the same idea, the same one, same interval. We are talking about the same time period. So it is just half second. So what about y2? It's just 6 meters minus 2 meters. So I will divide it by half second. So I will get 4 meters divided by half second. So that will be equal to 8 meters per second. What about the resultant velocity? I have two different velocities in x and in y. So I will put a triangle, okay. Here my Vx is equal to 6 meters per second. And here I have my Vy, which is 8. And here 6. So how can I calculate this one? Our resultant. How can I calculate this V? I will put my formula. Okay, V will be equal to Vx squared plus Vy squared. And V can be calculated 6 squared plus 8 squared. That will give me 10. And this is a well-known triangle. 6, 8, 10. It's a well-known triangle. And it is just double of 3, 4, 5 triangle. You know, 3, 4, 5 triangle is one of the spatial triangles. And here, as you see, it is 6, 8, 10. And it is just one of the spatial triangles. So here, actually, I found my velocity, my resultant velocity, actually. But what about the direction? Actually, I have an angle here. I'm moving with an angle. So my path is actually will be in this way, right? My path is not on the x-axis and is not on the y-axis. Actually, my path is in inclined way. So this is my path. This is my path. What about the angle? How can I calculate the angle? As I said, it is inverse tangent of Vy divided by Vx. So I will put arctangent of 8 divided by 6. That will give me the answer. So let's take our calculator. Put shift, then tangent. So that will give you the inverse of tangent. Put this one, 8 divided by 6. That will give you 53.13. And it is degree, okay? So I know the direction of the velocity vector and the magnitude of it. So I solved the question, okay? It's asking about the magnitude and direction of the average velocity, okay? So this is my average velocity. And why I'm talking about average velocity? Because maybe sometimes I will have an acceleration here. So when I'm at the beginning, I will be at rest. And when I will just reach here, I will have different velocities. I will just increase my velocity in some points and decrease my velocity in some points. Maybe I'm moving at constant velocity. I don't know. So by these informations, the initial point and the final point and time, you can only know what is your average velocity. But what about the instantaneous velocity? Instantaneous velocity means your velocity per each time. So when time equals to 0, here my time interval between 2 and 2.5, right? So what about our velocity when time equals to 2.2? Actually, I cannot know. By these informations, I cannot know. I must know what is my acceleration and what is my initial velocity. Then I can calculate what is my instantaneous velocity. That means velocity in each time. But in this example, I just have some limited informations that will just allow me to calculate average velocity. We will see in different examples. Actually, in the second part of chapter 3, you will see the acceleration, understand acceleration. Then you will be able to calculate the instantaneous velocities. Okay, so see you in the next video. We will solve 2 problems or 3 problems for velocity in a plane. So thank you for your participating.